5.1 Fundamental Identities. So all those identities we've been talking about since literally day one, we're finally going to start to use them all. So just as a reminder, we have reciprocal identities, so that cotangent is tangent, secant is cosine, cosecant is sine, and also the reciprocals of those. And then quotient identity, tangent is sine over cosine, cotangent is cosine over sine. Then we have our Pythagorean identities. So we have sine squared theta plus cosine squared theta equals 1. That's the Pythagorean theorem for the unit circle. We have tangent squared theta plus 1 equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. And then the even odd functions. Alright, we're going to be using all of these throughout Chapter 5 and more identities that we'll learn along the way. You do need to have every identity memorized. You are not given any of them for the test. In trigonomic identities, theta can be an angle in degrees, a real number, or a variable, right? It could be x, it could be theta, it could be in radians, it doesn't matter. So let's find trigonomic function values given one value and the quadrant. If tangent theta equals negative 5 over 3 and theta is in quadrant 2, find each function value. So for A, we're going to find secant theta. For B, we're going to find sine theta. And for C, we're going to find cotangent negative theta. So for A, what we're given, let's pull out what we're given. We're given tangent theta equals negative 5 over 3. And we need to find secant theta. Alright, so that's what we're given and that's what we need to find. So let's look at our identities to see what we can use. So we have tangent and we need to find secant. So looking all of our identities, usually start with your Pythagorean identities. That's a good place to start. So we have tangent. Let's mark off everything with tangent. So this has tangent. This is technically tangent because we know the reciprocal is cotangent. So that's technically, we could use that. And then we need to find secant. So there we go. We're going to use this one right here. Because we have tangent, we need to find secant. So we have 2 pieces out of the 3. So that's what we're going to use. Tangent squared theta plus 1 equals secant squared theta. Alright, so we have tangent. We're given that. And we need to find secant. So tangent, let's plug it in. It's negative 5/3. So we have negative 5 over 3 squared plus 1 equals secant squared theta. Alright, let's simplify the left side. Use your calculator. Simplify the left side with your calculator. If not, you know how to simplify the left side. So the left side, we get 34 over 9 equals secant squared theta. So we only need 1 theta. Since we only need 1 theta, we need to take the square root. So it's positive negative square root of 34 over 3 equals secant theta. Now, is it positive? Is it negative? Which one do we choose? We choose negative. We choose negative because we're working in quadrant 2. It tells us we're working in quadrant 2. So since we're working in quadrant 2, we choose negative. So since we're working in quadrant 2, secant is negative. So we use the negative for our value. So that means secant theta is negative square root of 34 over 3. So we found it. Alrighty, part B. We need to find sine theta. So write out what you have. Let's write out what we have. So what we have tangent. We're given that. We have tangent. So tangent theta is negative 5 over 3. And we just found a value. We found secant is negative square root of 34 over 3. So yes, we are allowed to use exact values we find. That's an exact value. It's a fraction. We didn't round anywhere. So we are allowed to use it. We need to find sine. So we need to find sine theta, and we have tangent and secant. So keep in mind what else we have. If we have tangent, we have secant, we also have the reciprocals of those. So keep that in mind. All right, we need to find sine theta. So sine, secant, tangent, that's what we got. All right, let's take a look at our identities to figure out which one we could use. Now, there's no one answer to this. I'm going to show you one way, but there's multiple things we could use. Because remember, sine is the same thing as cosecant. And then secant is the same thing as cosine. So we could, because we technically have cosine. We technically do. If we flipped the secant, we would have cosine. And we need to find sine. So yes, you could use this one. You could. Okay, let's see what else we could use. We have secant, which is technically cosine, or this is actually secant, and we have tangent, but nothing in there says anything about sine, so we're not going to use this one. Nothing in there says anything about sine. All right, cotangent we technically have because we have tangent, and then cosecant we don't have, but we are trying to kind of find it, right? Because cosecant and sine are reciprocals of each other, so we could use this one. But do you notice if we use one of those two, we have to use reciprocals? We have to flip some numbers. So let's see if we can do anything easier. So reciprocal identities, honestly, we're not going to use it to solve because we don't have. If we had the reciprocal, we would just flip it. Let's look at our quotient identities. So for our quotient identities, we're given tangent. So we technically have cotangent too, it's just the reciprocal. We have secant, which is technically cosine. So it's technically cosine. And we're trying to find sine. So we could also use that one, although we have to use another reciprocal. So it honestly does not matter. You could use any of the three that we highlighted. You will still get the same exact answer. For the notes and for this example, I used the quotient identity just so we could practice with something that I want to show you. So we're going to use the quotient identity. So the quotient identity states that we have tangent theta equals sine over cosine. Now, I chose to use sine over cosine because what I need to find is on top. So what I need to find is on top. That's why I chose that. If I need to find stuff and I'm using reciprocals and a bunch of stuff, I'm just going to try to use the one where whatever I need to find is on top of somewhere. So that's why I chose this one. But again, you could have chose any of the three. Okay, so we're trying to find sine. So before we plug in any numbers, let's get sine by itself. So to get sine by itself, we multiply by cosine theta. So we'll have cosine theta tangent theta equals sine theta. If you're wondering what goes in between, it's just being multiplied together. So let's plug in what we have. So we technically have cosine. It's as secant, though. So we're going to switch the cosine to 1 over secant. So you're always going to want to replace everything as the trig function and then plug in numbers. So we replaced everything with what we have. We have secant, we have tangent, we need to find sine, so that's why we flipped it. So now we can plug it in. So I'm going to plug it in up here. So we have 1 over secant theta. Well, the secant theta we found was negative square root of 34 over 3. And then that's times our tangent theta. The tangent theta we have is negative 5/3. And that equals sine theta. So now we can go ahead and solve for our sine. So this is where we have to keep, change, flip. So I'm going to bring this out to show us. So this part right here, it would be 1 divided by negative square root of 34 over 3. So that's 1 times 3 over the square root of negative 34. So this comes out to negative fraction 3 square root of 34 over 3. So I'm going to just replace that. So this comes out to negative 3 square root of 34 over 3 times negative 5 over 3. And that equals our sine theta. We can simplify now, so multiply straight across. So we have negative 3 square root of 34 times negative 5, so that comes out to positive. So we have positive 15 square root of 34. 3 times 3 is 9, and that equals sine theta. We can simplify this a little bit more because we can simplify the 15 and 9, so divide by 3, so we're left with 5, we're left with 3. So that means sine theta is 5 square root of 34 over 3. So part C is wanting cotangent negative theta. Alright, we know something about cotangent. We know cotangent negative theta would be the same thing as 1 over tangent negative theta. Since it's negative theta, we keep it consistent with negative theta. So all this means is 1 over negative tangent theta. Okay, let's plug it in. Now, how did I get that? It comes from the even-odd identities. If we have a negative theta, it just means you have a function that's negative. That's all that means. So we have tangent theta. We have 1 over negative. So tangent theta was negative 5 over 3. We simplify. And after we simplify, we get cotangent negative theta equals 3 over 5. So all this is saying is the negative reciprocal to tangent. That's all that is. So we could have just taken tangent, flipped it, and changed the sign. That's all it's saying. Take it, flip it, change the sign. Be careful. A common error when taking square roots, be sure to choose the sign based on the quadrant of theta and the function being evaluated. That's cast, so don't forget your cast. Alright, example 2. Writing one trigonomic function in terms of the other. Write cosine x in terms of tan x. Now, what the heck does that mean? So what that means is we want to make cosine x equals tangent x, meaning on one side we want cosine, and on one side we want tangent. That's all that means. And all we're given is cosine and tangent. But it's telling us to write cosine in terms of tangent, so that means we're going to start messing with cosine. So let's bring everything we know about cosine. We know cosine x is the same thing as 1 over secant x. So we have cosine, which is just 1 over secant x. Let's see if there's a Pythagorean identity that we could use that has secant, cosine, or tangent in it. So looking at our identities, always start with the Pythagorean. You're always going to want to start with the Pythagorean identities. So we're trying to find or make two things equal. We want to have secant and tangent now. So why secant? You'll see why. So I need to get cosine to equal tangent, meaning I want cosine and tangent in my equation. This does not have cosine and tangent, so that goes away. This doesn't have cosine and tangent, so that goes away. This does have cosine and tangent. That does. So because this is the cosine, that's the cosine. And we do have tangent. So we're going to be using tangent theta plus 1 equals secant squared theta plus 1. It is theta, but since we're using x, we replace x with theta, and that is the Pythagorean identity. We're using a Pythagorean identity. So we can use the identities and make them work for us because they're proven. They're proven identities. So we don't need secant though, we need cosine. Alright, so we have 1 plus tangent squared x equals secant squared x. So we have the tangent side, but we need the cosine side. Secant isn't cosine straight up. We need to change it to cosine. To change secant to cosine, it's the reciprocal. 1 over secant is the same thing as cosine. So to get cosine of this, we first need this part right here. So in order to get that part, we need to take the reciprocal. we need to take the reciprocal to get this side. So I need to take the reciprocal of secant. So we have 1 over secant squared x. And since we took the reciprocal of the right side, I flipped it. You have to flip the left side. We're trying. We're testing. Who knows if it's going to work? We're just trying. So I need to flip the left side. All right, now... see, I haven't used an identity. Doing this to this, we didn't use an identity. We forced it. But now we need cosine straight up. We need like cosine as cosine. So 1 over secant x is the same thing as cosine x. So now we're going to use our identity to make this just normal 1 cosine. So we have cosine squared x, and that equals 1 over 1 plus tangent squared x. Now we don't need cosine squared, we just want cosine, normal single cosine. So to get that, we take the square root. So we have plus or minus 1 over the square root of 1 plus tangent squared x. We can't simplify that because of the 1 and the plus in between. And that equals cosine x. Now we're not allowed to have that denominator, so all we do is just put it on top. So we have plus or minus the square root of 1 plus tangent squared x over 1 plus tangent squared x. And that equals cosine x. We don't know which quadrant we're working in, so we'd use plus or minus. We don't know which quadrant we're working in. It doesn't say quadrant whatever, so we just keep it as plus or minus. Rewriting an expression in terms of sine and cosine. We're going to write 1 plus cosine squared theta over 1 minus cosecant squared theta in terms of sine theta and cosine theta, and then simplify the expression so that no quotients appear, meaning no fractions. At the final answer, we don't want fractions, get rid of them. Alright, so what we're working with. I changed the example, my bad. I changed this to a t. 1 over it's 1 plus cotangent. So we're working with 1 plus cotangent squared theta over 1 minus cosecant squared theta. So what we need to do is simplify this so there's only cosine and sine throughout the entire problem, through the entire expression. Let's start changing our trig functions into cosine and sine because it's telling us to do that. It's telling us to write only sine and cosine with no fractions. So we know something about cotangent. Cotangent theta is the same thing as cosine theta over sine theta. So we're going to switch that. So we have 1 plus cosine theta over sine theta. And that's over. So now we have another thing that we can switch because we don't want cosecant or tangent or anything like that. We only want cosine and sine inside of our equation. So we can switch cosecant, right? We know what cosecant theta is. That's 1 over sine. So we can just switch that to 1 over sine. So we have 1 minus 1 over sine theta. So you see how we only have cosine and sine now? Awesome, right? We still have to simplify though. Let's get rid of our complex fraction by multiplying by the common denominator. So our common denominator is sine squared theta. So we're going to multiply everything by sine squared theta. Why? Because we need the same denominator in order to add fractions. So when we multiply that out, right, we distribute. So we have 1 times sine squared theta, that's just sine squared theta. Plus, so here our denominators cancel, so we're just left with cosine squared theta. And that's over, we distribute again. So sine squared theta. Minus, and here these two cancel. Well, so just minus 1. So here, this is what we're left with. Now we keep simplifying. How do we know we can keep simplifying? Well, let's look at our identities. Sine squared theta plus cosine squared theta. So looking at our identities, do you see sine squared theta plus cosine squared theta? What does it equal? It equals 1. So we're actually going to switch that. Yes, you have to switch it. This is simplifying. It's just knowing what to do. So we know using the Pythagorean identity, the Pythagorean identity states that we have sine squared theta plus cosine squared theta equals 1. So we're going to switch this to 1. Now, it doesn't want fractions, so we know we're not done yet. Let's see if there's anything more we can simplify. This is where equivalent forms come in. So sine squared theta minus 1, it comes from our Pythagorean identity. How does it come from our Pythagorean identity? Well, all we do is subtract 1. So now we have sine squared theta minus 1 plus cosine squared theta equals 0. We subtract it over. So we minus cosine squared theta to both sides, and that's how we get sine squared theta minus 1 equals negative cosine squared theta. So it's called equivalent form, meaning moving stuff around. So you can subtract and add things to figure out how it's supposed to look and work for you. So we know that sine squared theta minus 1 using the Pythagorean identity equals negative cosine squared theta. So we're going to switch this. Now we have 1 over negative cosine squared theta. Now the reason why we did that, because we're not allowed to have fractions. So to get rid of the fractions, I can't have plus or minus any functions. It has to be 1 over the function or function over 1. Alright, last but not least, we know something about this. 1 over cosine theta is the same thing as secant. So we're going to switch this to secant. And since it's negative, we're going to have negative secant. So we have negative secant squared theta. That is writing in terms of cosine and sine with no fractions. But you're like, it's not sine or cosine. Well, it is. It's secant, but no fractions. Because it says no quotients up here, we had to take that reciprocal and turn it into secant. When working with trigonomic expressions and identities, be sure to write the argument of the function. So meaning, don't forget your theta, don't forget your x. You do not write it. You would not write this sine squared plus cosine squared equals 1. You need the theta. If not, it's not the same thing. So make sure you have theta, make sure you have x, make sure you have that variable there.